Sample of 279 students at a particular university was taken, and the students were classified according to their major and their gender, and the results are given in the contingency table below. And let me move the screen over so you can see the whole table. Among the male students in the sample, find the relative frequency of those who happen to be biology majors. So they're talking about among the males, and so they've kind of restricted the sample space so that you're only on male street. So if you go down male street, how many of them are biology majors? So I'm on the male street, and I've got 25 that are biology. So I need to add up all the males majors. I mean, not all the male majors, but all the males. And so I'm going to add up their values there. So I'm going to add in, gosh, I don't think you can see it. Yeah, I'll just move it around. So there's 25 for the males that are biology. So I'm going to hit divided by 25 plus, there's 16 plus 34 plus 15 plus 39. So those are the values of for all the males: 25, 16, 34, 15, and 39. And so that'll give us the relative frequency of the biology majors for the math. So it's 0.193, and they say round your answer to 2 decimal places, so 0.19. And so we plug in the value 0.19. So our next question says, below is the graph of a normal distribution. It has a mean of -2. You can't see it on the screen, but the standard deviation is 2. The shaded region is the values between -1 and 6. And they want us to draw the corresponding region for a standard normal distribution. And that will be where the mean is 0 and the standard deviation is 1. So not mu equal to -2 and a standard deviation. Oh, I didn't mean to hit that button. Of sigma equal to 2. So what we need to do is we need to find the z-scores for this -1 and then also find the z-score for the -6. So let's do that real quick. So the z-score is given by x minus mu. So we're going to do the -6 first. I'll do the leftmost endpoint first. So we're going to do -6 minus the mean of -2. I'm going to put that in parentheses, divided by the standard deviation of 2. And we can see here that we're going to get a z-score that is equal to -2. So that's the z-score for the first one. I'll just store it just in case I forget. All right, so now let's do the z-score for the other one. Oh, you know what? If I hit the undo, that would have been better before I stored it. Oh, well, that's not so bad. All right, so then we're going to have -1 minus -2 divided by the standard deviation of 2. So that's the other x score. So we have -1, and then you can't see it on the screen, but there's a -6 as well. And we got 0.5. So recall was -2. So we're going to go from -2 to 0.5. So I'm going to draw a vertical line at -2, and then another one at positive 0.5. And then I'm going to shade the region in between. So that will be the same area as this curve here. All right. Then let's go to the next question. The producer of a weight loss pill advertised that people who use the pill, people who use the pill will lose after 1 week an average of 1.75 pounds with a standard deviation of 1.02. In a recent study, a group of 50 people who used the pill were interviewed. The study revealed that these people lost a mean of 1.9 pounds per week. If the producer's claim is correct, what's the probability that the mean weight loss after 1 week on this pill for a random sample of 50 individuals will be 1.9? So let me read that again. So we have here that after 1 week of using this pill, they lost an average of 1.75 with a standard deviation of 1.02. Then they took a sample of 50 people, and they lost a mean of 1.9 pounds, not 1.75. So they want to know what's the probability that the mean weight loss of 1 week on this pill for a random sample will be 1.9 pounds or less. So let's capture all that information in Word. All right, so they tell us that the mean is 1.75. So mu equal to 1.75. And the standard deviation is equal to, I think it was 1.9, but I'll go out and double check it. And then we had a sample of 50 people, so n equal to 50. And we want to know for this n equal 50 that, no, I don't think 1.9 was the standard deviation. Let me go grab that. I think that was the average for the sample of 50 people. So, alright, so here we go. Hey! My little laptop, it has got a little funky little dude here. If you don't select it right, it gets cuckoo. Alright, so that's X bar. You know what? I'm going to keep typing that in. I'm going to just put it up here so I can have it. Alright, so X bar is equal to something. Let's read the problem. Yeah, it is 1.9. Standard deviation was 1.02. Okay, so 1.9, it says it here. You can't see it, but it says will be 1.9 pounds or less. There it is, or less. Okay, cool. All right, so let's go out to our equation and capture that. Okay, so 1.9 or less, and this was 1.09. All right. So I want to find the probability that x is less than or equal to 1.9. And there's actually a less than or equal symbol on this little guy. Woo-hoo. So that's what we're actually trying to find, is that guy. But now here, this is for a sample mean, so not x, but x bar. So we need to find the z-score that corresponds to this one. It looks very much like the z-score that we had before. So let me see if I have that in my equation up still. Yeah, I don't. Okay, that's all. So let me go out and grab it. Oh, you know what? It's opening up another movie that I had. Oh, I can't find the controls to turn it off. Hey, come back here. Oh my goodness, seriously, I have everything up with unknown to man. How about pause, you woman, pause. Okay, cool. All right, so let's capture the formula for the z-score when we have a sampling distribution. So this isn't one particular x value. This one here is a sample of 50. So it turns out z is equal to x bar. Yeah, I'm so glad I grabbed that. X bar minus mu. Yeah, I should grab that in there too. Minus mu. Hey, come back here. Actually, it's really mu sub x bar, but it's all good. Mu divided by let me close this guy because that's distracting for me. Okay. There we go. All right, divided by sigma over the square root of n. Boy, I tell you, it's been a lot easier to write this in. Yeah. But that's okay. Over the square root of n. All right. So there's how you can see it. I don't know what happened to sigma, but we'll fix it. Control X, Control V, and oh, there's that formula. All right. Sigma. All right, so that's our formula. And it turns out here mu sub x bar, which is the average of the sample means, is equal to mu. And sigma over the square root of n is equal to sigma of x bar. And the only reason why we can do this substitution is because n is greater than 50. Excuse me, n is equal to 50, which is greater than 30. So the fact that n is large is what allows us to use the z-score. So they have here that the n is 50. So that's why we can do what we're doing here. All right, so then let's go out to the ALEKS calculator and substitute in our value now that you have the formula. Let me type it here so you can see all the creatures that we're going to put in. So I'm just going to copy this and then replace. Copy this and plug in the values. So the average for this was 1.9. The mean was 1.75. And the standard deviation was 1.09. And the n was equal to something, 50. All right, and so we're going to go ahead and do that computation on ALEKS. Thought I closed this. Oh, I know what happened. Never mind. No. You know what? It's going to time out because I took too long. It's all good. It is all good. I hope it won't. All right. So we're going to do 1.9 minus 1.75 divided by sigma. Oh, it's 1.02, not 1.09. Sorry, fix that. 1.02, not 1.09. Divided by the square root of 50. So out here on the inline equation here, this should have been 1.02. Yeah. Sorry. 2. All right. And so when we compute that z-score, we want to find that it's 1.9 or less. So let's go ahead and compute that guy. And it's 1.039, and they tell us to carry it to 4 decimal places. So I want to find the probability that p is less than that guy. So if you wrote it on your paper, it would be 1.0397. No, 1.0399. So that's equal to 1.0399. Just in case the ALEKS calculator freezes, it's just good to capture some of this stuff. All right, and so then we'll go out here and then compute the probability using ALEKS calculator. So I'm just going to find that probability. So it's 1.9 pounds or less, so I'm going to do less than or equal to. And we get 0.85, and they want you to round your answer to 3 decimal places, so 0.851. Oh my goodness, 0.851, seriously? I'm having a little issue, you guys. Alright, now that's 3 questions. The urn contains 4 orange balls and 7 yellow balls. If Vince chooses 5 balls at random from the urn, what's the probability that he will select 2 orange balls and 3 yellow balls? Round your answer to 3 decimal places. It's kind of like the problem we had earlier with the committee where we had 2 women. And we had 4 out of the 9 were women. But this one's a probability, not how many ways. So it turns out we want to have how many balls here? We want 2 orange balls and 3 yellow balls. Okay, so 4 choose 2 because there's 4 orange balls. 4 orange balls, and I'm choosing 2. And then 7 choose 3, all out of, he's going to choose 5 balls from a total of 11. Okay, so let's capture that in Word. So it's going to be, I forgot that quick. Oh my goodness, seriously. 4 choose 2, 7 choose 3. All right, so 4 choose 2, 7 choose 3, and we're going to divide all of that by 11 choose 5. And then if you check it out here, 4 plus 7 is 11. That's that top number because there's 4 of the one color and 7 of the other for a total of 11. And then we're only picking 5 balls, 2 from the first color, 3 from the second. All right, so let's go ahead and type out that computation, and I'll do math type to do that. Okay. So I need 4 choose 2. So that's going to be 4 factorial divided by 2 factorial, 2 factorial, and then 7 factorial. Oh, that's a big multiplication symbol. How about that one? All right, I'm having way too much fun. Okay, now this is going to be 7 factorial, and then 4 factorial, and then 3 factorial, all divided by 11 factorial. I am like burning up. I don't know what is going on with me. I know what's going on with me. I'm eating really. I think I had some MSG is what I think I did. Okay, it's getting mad. It's my mouse. Come on, I don't want this movie to be 20 minutes long. All right, 11 choose 5 is going to be 6 factorial and then 5 factorial. All right, so let's scroll down just so you can see that a little bit more. Yeah. Beautiful. All right. All right, so then here the 4 times 3 and the 2 factorials will go away. So you have 4 times 3 over 2 times 1, which is 6. Because I think we did one of those actually earlier in the verse. So the first guy is 6. And then you're going to have on the top for the next guy. All right, and then you're going to have 7 times 5 times, 7 times 6 times 5 over 3 factorial. I'm just going to do it this way, you guys, because I'll be all night trying to click that crazy button. All right, so that's the second guy. And how about, that's supposed to be a 3. And that is not going to work. Oh, cool. The 3 times 2 will cancel with the 6. So it'll just be 7 times 5, which is 35. So it'll just be 6 times 35. You know, there's probably something that'll cancel on the bottom. I didn't catch that. Oh, well. All right, all of this divided by, oh, man, I'm having trouble with my allergies. All right. So 11 times 10 times 9 times 8 times 7, and the 6 factorial will go away, and then I'll have the 5 marched out on the bottom here. Come on. 5 times 4 times 3 times 2 times 1. Yay! All right, so the 5 and the 2 can cancel with the 10. So I'm going to erase that real quick so I can keep track of what I erased. 5 times 2 will cancel with the 10. All right, and then the 4 will go into 8 2 times, so I'm going to change that 8 to a 2. And 3 will go into 9 3 times, and that'll become a 3. Cool. Cruella. All right. When I was right. That 7 could cancel with the 35 and make that a 5. All right. All right. So this 2 and 3 canceled that 6. And I had 35 there, but now that 7 that was down here canceled with that 7. So that's why I only have a 5 on top. Divided by 66. Ooh, wait a moment. And then this 2 and 6 can cancel with this 6. So you just have 5 11s. I hope I didn't do that too fast for you. Oh, they want us to round. Oh, this is not good. If the movie's too long, I don't want to do a fourth movie, but I'm going to have to. Shoot. It's taking too long. I'm just going to use a regular calculator because it's irritating me. So 5 divided by 11 is 0.4545. It repeats. I think it's because it's timed out. Round your answer to 3 decimal places. So 0.454. No, 5. 0.4545. Yes. 0. All right. All right. So the last one is the control department. A light bulb manufacturer picks 4,400 light bulbs from the production lot, and the records show that when there is no malfunction, the defect rate in the manufacture due to imperfection is 1%. When 1.2.5% or more of the light bulbs in the sample are defective, the control unit calls repair technicians. Find the mean of this. Oh, this is the sampling distribution for proportions, so the mean is just equal to P. So the record shows that when no manufacture, the defective rate due to imperfections is 1%. So it's just going to be 1%. So 1% is 0.01. All right. And the standard deviation is given by the square root of 0.01. So I'll just type it on the calculator. So it's equal to the square root of 0.01, 1 minus 0.01, which you could just put 0.99, divided by n. And I think there was 4,400. Oh, you see that, you guys? See the point? Oh my goodness, I didn't put the decimal. I didn't put the division bar in the right spot. You have to have a microscope to see that. Oh my gosh, really, seriously. All right, that's why you should have 0.01. You wouldn't make that mistake. Anyway, yeah, put 0 in front of that. If you put a 0 in front of that, then you'll be able to make sure you don't put the decimal in front of the division bar. Okay, cool. And so you get 0.0015, Control C. Come on, I'm trying to submit this. 0.0015. Alright, now we want to find the probability that p hat is greater than 0.0125. So we just need to find the z-score for that. And so the z-score is given by 0.0125. Store this value. So 0.0125 minus the mean, which is the answer to part A, which is 0.01, divided by recall, which is the 0.0015. That was the standard deviation. So we find that, and then we just find the probability that z is greater than that, because this is a greater than button here. So I highlight this guy, and p of that, and I got to do 1 minus, because that does less than or equal to, and we want greater than or equal to. Now, if it said less than, we didn't have to do the 1 minus. And we get 0.0477, and round your answer to 4 decimal places. So 0.0478. All right, last question. Oh, yeah, we love it. That's a nice one. So to find the expected value, just multiply the value of the random variable times the probability. So I'm just going to put the calculator right there. So I'm going to do negative 10 times 0.05 plus 0 times 0.05. I'm going to skip that. 10 times 0.35 plus 20 times 0.30 plus 30 times 0.15 plus 40 times 0.1. So let me make sure I put it all in right. So negative 10 times the first, 10 times 0.35, 20 times 0.3, 30 times 0.15, 40 times 0.10. And I skipped the 0 because we know 0 isn't going to make a difference there. So it's 8.05. So that there is the variance. I mean the expected value. 0.05. And then I'm going to store that. All right. Oh, shut up. I can't believe I just did that. Oh my gosh. I'm trying to rush, and since I hit store, the undo doesn't work. Don't hit store. So that means I have to re-enter it all in again. I cannot believe I did that. It's all good. So now I need to put that -10 in parentheses because I've got to square it, and I want to make sure I square that negative number. It'll become positive. Times 0.05. Plus 10 squared times 0.35. Plus 20 squared. Had I not hit the store, I could have just put x squared in front of all these guys and not have to retype in all this stuff. 0.30. How about put a point there? Don't want to miss it. All right. Plus, I'm trying to rush because I'm trying to finish and I'm just like so frustrated. This is all good. 30 squared times something. You know what? Half of you aren't going to even watch this. But the ones who do, I'll appreciate you. Don't be mad at them, Donna. All right, 40 squared because you made a promise and now you don't want to keep your commitment, you little peanut head. Okay, here we go. Oh, minus 8.05 squared. All right, let me make sure I put it all in right. Woohoo! Come on, baby. So -10 times 0.05. The 0 I skipped. And then 10 squared times 0.35, 20 squared times 0.30, 30 squared times 0.15, 40 squared times 0.10 minus the mean squared. That'll give us the variance. And so it's 390. How many places? Maybe they don't tell us around. Control C. Control V. Let me just make sure they don't tell me here. You know, it doesn't say anything about rounding or not rounding, huh? Well, let's put it all in there. Submit the test! Okay, let's see how I did. Oh, shut up. I missed the variance. What the heck did I do? I think that first one's wrong. I don't know what the heck I did wrong. But because I jacked up this guy, if you take this guy and add 8.05 squared to it and subtract 17.5, I bet we got it right. Alrighty then. Thank you so much for your... I can't believe I missed the easiest problem on the test. But it's all good in the neighborhood. Alrighty, friends. Thank you. This movie is so long, I don't think it's going to upload. Oh well.